Hello everybody, greetings. My name is Suranga Kasturiratna and welcome to my presentation on the OpenMRS HL7Query module. So during this presentation I will cover the following topics. I will speak on the general idea behind the OpenMRS HL7Query module, key use cases and the entire design process. I will also elaborate on what features the module currently supports. We'll look at what HL7 message types the module contains by default and study their structure in relation to the OpenMRS data that each segment contains. Next, we'll look at how to configure the module for our use. We'll look at the properties that need to be set and how to make calls on the module. Finally, we'll look at how developers can extend the module and how it can be modified to meet a wide range of use cases and HL7 message types. So last but not least, we'll wrap everything up with a practical demonstration of the module and how it can be used. So moving on to the origins of the module, let's answer the questions what, how and why. So the HL7Query module provides a way to export OpenMRS data in HL7 message format. OpenMRS data is translated into HL7 message objects based on a predefined model and returned to users. The entire process is asynchronous. There is no queuing or waiting for an output. The module supports both XML and pipe delimited format of HL7, and users can switch between both message types very easily. The HL7 messages are populated with data based on GroovyScript code, which can be edited based on your own preferences. So next slide, we will discuss why. So why did we develop this module? So firstly, prior to the HL7Query module, there was no universally agreed method on how to export OpenMRS data as HL7 messages. We already supported data input in the form of HL7 messages. This was available as part of the OpenMRS core for quite some time. However, not a lot of work had gone into planning the reverse end of this process, as in how to export data as HL7 messages. So of course, several implementations were already exporting data in HL7 message format, but all these methods were extremely implementation specific. So all this came to an end one fine day in April 2012 when we at Gembi Health Systems looked at the existing solutions and realized that we had the same requirement and none of the existing solutions actually matched what we needed. So basically, one email to the dev list led to another, and we found that a lot of people had a lot of different ideas on how they would want their HL7 exports to work. So we considered a lot of ideas, we had a lot of calls, we had a lot of discussions, and gradually the message began to fall into shape. Much of the core work on the module was completed by our core developers during a 2-week sprint held in August this year. So let's talk about how we model the HL7 message structure so that it can be configured to meet everybody's needs. Now, as you know, there are a number of different HL7 message types. Each message type can be broken down into different segments, and each of which is composed of many different fields. For example, the ORU-RO1 message type, which is included in our module by default, is composed of a number of subsegments: the message, the PV1, the PID, the OBR and OBX. There can be 0 or many OBR and OBX segments in your message based on how you map your data. Some segments are mandatory while some are not. There are different schools of thought on exactly how OpenMRS data should be mapped to HL7 message fields. For example, we at Gembi modeled our data on one specific design, while our conversations on the OpenMRS mailing list brought to light very many other different ideas on how the messages should be mapped. So ultimately, the HL7Query module was designed so that the end users themselves will have ultimate control on how the message structure, the design would look like. In short, you are responsible for the validity of your message structure and contents. We are only supplying a tool which helps you to design your messages more conveniently. So design continued. So how did we do this? So firstly, we designed our system so that it can be expanded to meet all potential scenarios. we created a hierarchy of message segments with parent templates representing the complete message structure. Each parent template could call one or many child templates, while who in turn could also call many other templates of their own. So child templates generally represented HL7 message segments and fields. So this approach made it possible for users to configure their own messages by either introducing new child templates and calling these, or editing existing templates in order to suit their needs. Furthermore, we are not just limited to just ORU RO1 messages. Of course, ORU RO1 is what's available by default, but if you want any other message type such as ADT for example, all you need to do is write up a new set of templates and trigger those via your calls. It's that simple. So moving on. So we'll look at the template hierarchy in a more detailed way. So I have given an example URL here on where I have more details on how the template hierarchy works. But to elaborate with a short example, the ORU RO1 message contains the PID segment, which is supposed to contain the PID3 segment, which in turn describes the patient identifier. Now, as in OpenMRS, a patient may have many different types of identifiers. So one implementer might say, I want just one identifier. Maybe give me the implementation specific user identifier, for example, and others might say, no, give me all different patient identifiers that the patient has. So using this, what the users can do is edit the message templates or introduce new ones where they can define their own behavior. One guy might say, oh hey, I want all patient identifiers, so my PID template will represent that, will reflect that, while the other says, I want just this specific identifier only, so I will be having my PID template with just that one identifier. So moving on. So let's look at one more design consideration, why we are not using mirth. So firstly, we have nothing against mirth. In fact, implementers can use the module and extend on it by integrating it with mirth. This way, the module will create the messages and mirth will take care of routing the messages on to the required destination. However, the HL7Query module does not offer out-of-the-box mirth support, mainly because we don't want to build a dependency with mirth. So implementers are free to take our HL7 messages and do as they please with it. You're welcome to not use mirth, you're welcome to directly feed the message into mirth itself. It's all up to you. So moving on, slide number 9. So now let's take a look at setting up the module. Setting up the module is fairly easy. You just need to install it and set a few global properties. We'll be looking at a practical example of how we do this later on during the demonstration, but I'll walk you through the steps now. So basically, the HL7Query module requires at least OpenMRS 1.82. Furthermore, you also need to set a few message fields that can be implementation specific or user specific. So at the moment I'm talking only about message fields that might need specific user input. But of course, later on when you're developing other message types, there may be other fields that might need to be implementation specific. So of course, all you need to do is add the new global property to the settings page and ask your administrator to set these values before someone starts using the module. It's that simple. So to elaborate on the message example, let's say that we need to specify the name of the parent template of the HL7Query message type that you want to use by default. For example, in this case, we want the ORU RO1 message type. So what we will do is, unless specified otherwise, the HL7Query module will always return the message type, this message type, based on its specification on the settings page. So if you look at the settings page, you will see that we have specifically called for the ORU RO1 parent message type, template type, and that is why it's being always returned. So if you have your own parent type, all you need to do is specify that as your parent template in the settings page, and the module will return that message. So next, you also need to set other message specific parameters such as internationalization code and message type in order for the current module to work. And last but not least, you also need to set an implementation ID for your implementation. The implementation ID is used as a last ditch resort to map any concepts you wish to export. By default, the HL7Query module attempts to identify exported concepts using their name and mapping such as NOMAD and LOINC. But assuming that your concept in your database hasn't got any mappings, we are going to need at least the implementation ID in order to attempt to map it successfully. So that is why we have made it a requirement to add the implementation ID to the settings page.